We're going to look into the laboratory preparation of oxygen. Under the preparation of oxygen, we have two ways. One is use of hydrogen peroxide, and the other one is using sodium peroxide. Both are compounds of peroxide, but you need to know the difference from the experiments and why is it convenient. From this setup, you can see that the round bottom flask, we have a dropping funnel, we have hydrogen peroxide in the dropping funnel, we have manganese 4 oxide inside the round bottom flask. We have a tray, then there is water and a fan, so fill the basin with water halfway. Okay, what is below the basin is a beehive or a stand. Then you fill the gas jar with water and invert it into the beehive or a shelf stand. Clamp the round bottom flask and set the apparatus below. When you release the hydrogen peroxide into the round bottom flask, you'll observe an effervescence. And that effervescence releases a gas which is colorless and odorless. Odorless means that it has no scent and has no color, it's colorless, which is indicated by the presence of bubble in the water. Now, the method of gas collection can be referred as overward or upward delivery or downward displacement of water. The gas can be collected through the method stated because it only slightly soluble in water. Oxygen is slightly soluble in water. Now, the purpose of using manganese 4 oxide is because it acts as a catalyst. And what's a catalyst? A catalyst is a substance that speeds up the rate of a chemical reaction but remains chemically unchanged at the end of the reaction. That means that the main purpose of a catalyst is to just aid the reaction, but it's never used up. So you see its proportion from the start and to the end, they are always the same since catalyst is never used up in a chemical reaction. Hydrogen peroxide decomposes slowly from water and oxygen gas. That means the hydrogen peroxide is a combination of hydrogen and oxygen. And in presence of manganese, the hydrogen peroxide decomposes to form separate compounds, that is water and oxygen. A little manganese 4 oxide speeds up the rate of decomposition by reducing the time taken for a given volume to be produced. Okay, here is a reaction equation. We have the hydrogen peroxide which decomposes to form water and oxygen. As you can see here from below, after the equation there is a H2O2 which gives you water and oxygen. After producing this oxygen, see, we had a gas jar. If you take a glowing splint and insert it into the gas jar containing the oxygen, it rekindles. Rekindling means that it glows. It's more like it has been, you are inducing it. It produces a very clear flame. That means oxygen rekindles a glowing splint, which is a confirmatory test for the presence of oxygen gas. I hope after there you have made you have realized that when you use hydrogen peroxide, you use manganese 4 oxide, and manganese 4 oxide acts as a catalyst. You need a glass jar, a beehive, basin with water, and you need hydrogen peroxide in the dropping funnel. That's how you produce you produce oxygen gas using the hydrogen peroxide. And how to confirm the test? You need to use a glowing splint. We insert it into the glass jar, then it rekindles or it lights. That's how you'll confirm that there is presence of oxygen. Our second point is using of sodium peroxide. Here, the diagram here is close to similar to the above, but the difference is here we have sodium peroxide instead of manganese peroxide. In the dropping funnel, we have water instead of hydrogen peroxide. I hope you are noting the difference. Then the rest is similar. When you release water into the hydrogen peroxide, you will see a fizzing or effervescence or bubbles being produced in the glass jar, which indicate that there is production of a gas. And since the gas is colorless, you can't see, but the bubbles will be a confirmatory test that the gas is produced. And the gas is also odorless, it has no smell. The gas is collected over water method because we had already said that oxygen is likely soluble in water. That's why it's easily to be collected over water. The confirmatory test for here again, we use a glowing splint. You take it to the mouth of the gas jar, then it rekindles. Okay, when you take sodium peroxide plus water, you'll get sodium hydroxide. Sodium peroxide, sodium reacts with water to give you an hydroxide. That means a combination of sodium and anhydride. And then you'll get oxygen too. Yeah. Na stands for sodium, O2 is for oxygen, H2O, that means H2O is water. Then you'll get sodium hydroxide. OH is the hydride, that is the hydroxide. Then O2 we have said that it's the gas. You can also prepare it using potassium chlorate. Yeah, it is written below. That is potassium K chlorate, which is O3, ClO3. Yeah. And now we are going to look at the uses of oxygen. Oxygen is put in cylinders used when natural supply is not sufficient, and include places like mountain climbers, deep sea divers, sea life, saving life in hospital. I hope you have all seen this one. If you see those who are going for deep diving, they always have a gas cylinder in the box. That's mostly where you have it. They carry oxygen to be used. Yeah, the mountain climbers also. Hospitals, you'll find that there are gas cylinders with oxygen, either with other gases. It's not only gas cylinders with oxygen, but there are other gases, but oxygen is used to supply when it's not enough. And then a mixing oxygen and some other gases produce a flame. It's very hot. Example, the oxyacetylene or ethane flame is produced when ethane and acetylene gas is burned in pure oxygen. Yeah, the flame has a temperature of about 3000 degrees Celsius, which is used for welding or cutting metal. Oxyhydride flame is produced when hydrogen is burnt in pure oxygen. The flame has a temperature of about 200 degrees Celsius. It's used for welding or cutting metal. Oxyhydride mixture is used in rocket fuel. I hope you are noting it. Then a mixture of charcoal, petrol, and liquid oxygen is an explosive. So used in it's put in cylinders, and where natural supply is not sufficient, it's used in welding. That is when combined with other flames. Mm-hmm. Yeah, and then it's used as rocket fuel and also it's explosive. A mixture of charcoal, petrol, and liquid oxygen is explosive. Until then, let's meet again next time. Thank you.